This is 4-3, rate of change and slope. The rate of change is defined as the change in y over the change in x. It's very similar to slope, but rate of change may not be constant, whereas slope of a linear function has a constant increase, we learned earlier. And we'll get more into slope in section 4-4, but we will start it in this lesson as well. So the biggest thing you need to know right now is that rate of change is the change in y over the change in x. So in this word problem, it says the table shows the cost of mailing a 1-ounce letter in different years. Find the rate of change and cost for each time interval. So that's what we're going to do first. We're going to find the rate of change, and then we'll be able to answer the next question, during which time interval did the cost increase at the greatest rate. What we need to know is that the year is our independent variable, our x, and the cost is our dependent variable. The cost depends on the year. That's going to be our y, dependent variable. Okay, so now I'm able to find the change in y over the change in x for each interval. So the first interval that I'm going to look at, I'll highlight in green here, is from 1988 to 1990. So I'm just going to write down below 1988 to 1990. And I want my change in y over my change in x. So if I look at the y's, we are going from 25 to 25. So our change in y is nothing, 0. And our change in x from 1988 to 1990 is 2. So I'm going to write that as my change in y was 0 over my change in x, which is 2. If you put that in your calculator, 0 divided by 2 gets us 0. If it was 2 divided by 0, it would be undefined. Okay, so I'm going to look at my next interval now. I'll highlight that one in blue. So the 1990 has to be shared with the 1991. So we're looking at two numbers at a time, but we have to make sure to include 1990 again. So from 1990 to 1991, 1990 to 1991, we're looking at our change in y first. So the change in y from 25 to 29, let me point to it. So change in y, 25 to 29 is 4, and my change in x is 1. So that's 4 over 1, which is 4. Okay, my next two intervals, I'll highlight those in yellow, from 1991 to 2004. 1991 to 2004. From 29 to 37 is 8 over 1991 to 2004 is 13. 8 over 13, which is about 0.62. Our last interval, 2004 to 2008. 2004 to 2008 has a change in y. It's going from 37 to 42, so that's a change of 5 over the change in x, which is 4. Oops, 5 over 4 equals exactly 1.25. And now we're able to answer. So we found, says find the rate of change in cost for each time interval. We just did that. Next, during which time interval did the cost increase at the greatest rate? Our largest number is 4. So this is the time interval, 1990 to 1991, where it increased at the greatest rate. So like I said in the beginning, rate of change has a lot of steps. It's the same thing every time, change in y over change in x, but we're doing this multiple times because it's not a constant rate of change in this problem. There's no constant increase. This is not linear. It's not going 88 to 90 is plus 2. Then next one would have to be 1992, 1994 for this to be linear, as well as an increase, constant increase in the y, and that's not happening. So that's why we have all these different varying numbers for our rate of change for different time intervals. So slope is the same as rate of change in the sense that it's the change in y over the change in x. So let me highlight where it says that down below here. Slope is rise over run, but it's also change in y over change in x, which is what we were just doing. okay? A quicker way is to see how much it's rising because the y is a vertical line. So it's either going to go up, which would be positive, or down, which would be negative, but that's rising. So we can actually rise up or down in this case. And for the change in x, we call that running. So if you have an x-axis, like here, okay, when you go to the right, it's going to be positive, and when you go to the left, it's going to be negative. And so you run along the x-axis and you rise on the y-axis. So rise over run, think of y's over 1, how I told you Jackson said it last year. So it's got the y on top over the x, change in y over the change in x. And the way that looks, if we look at this red line that's provided here for us, this red line right here, I'm looking to see from one point, like this red point down here, to the next point, how much I'm rising. So if you were telling me to walk to this point, only by going up and down or left or right, you would tell me to rise up first, 1, 2, 3 spots. So I rise 3, and then you would tell me to go to the right, or positive, go to the right 2 spaces, 1, 2. So I'm rising 3, running 2, which means that my slope for this is 3 over 2. Okay, and every time that's happening, I'm rising 3, this is constant, it's going to be constant because it's linear. So again, I go to my next point, and I'm rising 1, 2, 3, running 2, 1, 2. Rising 1, 2, 3, running 2, 1, 2. I'll show you a couple of these so you can get used to the rise over run. Find the slope of the line that contains 0, -3, and 5, -5. So I'm going to start by plotting those points. 0, -3, since the -3 is in the y spot, that would mean it's going to end up on the y-axis. And 5, -5, that's 5 on the x, -5 on the y. So here's my line, and I want to find the slope of this, the change in y over the change in x. Delta y over delta x is a shortcut for writing change in y over change in x. So I can do a couple of things. I can rise and run, or I can see how much my y is changing. So to get from -3 to -5, I went down 2. To get from my change in x, to get from 0 to 5, I went up 5. So my answer is -2 over 5, and I can see that with my rise over run. This isn't the best graph, so it's a little bit harder with the graph, but to get from this point to this point, since we read left to right, I'm just picking to start here and get to my point further to the right. So if I'm here, I'm going to go down 2, 1, 2, and over 5, 1, 2, 3, 4, 5. And that's how I know my slope is -2 over 5. If I chose to start here, it still works. I would go, to get to my other point, for my change in y, I'm going up 2, so +2, and then I'm going left 5, so -5. When we go left on the number line, it's negative on the x-axis, which is like a number line to me. So -1, -2, -3, -4, -5 spaces to the left, okay? And so that would be, if I did it that way, I would get 2 over -5. But regardless, it doesn't matter, because these that I circled are the same. They're really just both -2/5. As long as there's one negative sign, my answer here is negative. If I had written -2 over -5, that'd be a different story, because when you're dividing, 2 negatives make a positive. So that's not the case. As long as it has one negative somewhere in the problem, it's the same slope. To find slopes of horizontal and vertical lines, you can actually just memorize this to make it easier. But if you're finding the change in y, for example, A here, let me get my pointer up. The change in y, well, the y isn't changing at all. But the change in x is that it's running over 4. 1, 2, 3, 4. Okay, so the y didn't go up or down. This line doesn't go up or down, so the y is 0. But the x, it goes over to the right 4, so +4. So change in y is 0, change in x is 4, 0 over 4 is 0. So the slope of any horizontal line is going to be 0. Think of a car. If a car were sitting on this right now, and you didn't you didn't step on the gas, it would go 0 miles per hour because it's just a completely flat road. Whereas if you tip the line up or down, the car would roll either backwards or forwards. Okay, so for this line, example B, that's straight up and down, the y is changing. So if you go from this point to this point, the y is dropping 2. It's going down -2. And it's not changing at all in the x, so it would be -2 over 0. They said 2, 0, which is fine. They started at this point, and they're telling me that you go up 2, but it still has a run of 0. It's not going anywhere on the x. So 2 over 0, if you divide this in your calculator, 2 divided by 0, you'll get an error because you cannot divide by 0. So therefore, any vertical line is going to have a slope that's undefined. And think about this. If you put a car on a hill like this, we don't know what the result would be. So therefore, the slope is undefined. These are all our different slopes now. So if we look at the first one, just keep in mind that we always read from left to right. No one explained this to me. So picture is like someone starting always on the left. If they were going to start walking, they'd be going uphill, and that's why this is positive. Okay, so again, someone's starting on the left, so we'll go to the starting point on the left here, which is right here. And if someone's walking here, they'd be going downhill, negative slope. Okay, if someone's standing here, this is our 0 slope. Like I said, if there's a car sitting here and you didn't press the gas pedal, it would go nowhere, so it's going 0 miles an hour. And this would be your undefined slope. Vertical line, if you had a car driving along, gets to this right here, this would be an undefined situation. We don't know what the result will be. Keep in mind also that if you have 0 over a number, think of this like a person. They're okay here, their head's on top, that's 0. But if you have an upside down person, number over 0, this is no good. This is undefined as we calculate, okay? If you're calculating a positive slope, like for instance maybe 3/5 or just the number 6, those are positive. But if you have a negative slope, you should end up with something like -4 or maybe -2 over 3, which is the same as 2 over -3. Either way, they're negative.